Okay, welcome everybody. We're here today to talk about the Oracle Exadata Database Architecture Revolution, hot topic certainly with a lot of our customers. We'll be talking about how Exadata is certainly turning the architecture world upside down when it comes to database infrastructure. Now in its fourth incarnation in terms of evolution. We believe this latest product release version, which is X3, is certainly a key milestone, a major milestone in terms of its evolution. Before we get into the details of the event today, we'll talk a little bit about Cintra in terms of a quick background. So Cintra is a 16-year-old organization here established in New York with established offices in the UK and the US, covering both East Coast as well as the majority of the UK. And we are a specialized expert database excellence center when it comes to Oracle infrastructure technology and business intelligence data warehouse technology. We have built a reputation on the back of being trusted architects and advisors to our customers. And this page really reflects what we're about in terms of having the highest level of accolades, certifications, and credits when it comes to Oracle background, which covers all aspects of the core technology when it comes to database, performance tuning, warehouse, Golden Gate replication, and now, of course, engineered systems as well with Exadata and the database appliance, as well as new appliances that we'll be talking about as things evolve. So in terms of our architecture, again, keeping the sales pitch to a minimum, really just speaking about our primary pillars when it comes to our offerings as service providers is we are focused on driving true business value from database technology. That's a common thread and theme throughout Cintra's solution services and consulting offerings, directly tuned in and focused on increasing business value and efficiency by eliminating inefficiencies in commonly found database infrastructures, increasing value back to the business, increasing the agility of businesses' ability to turn to new initiatives and support new applications and business demands. Overall, providing all of that the highest level of availability, performance, and security, and ultimately looking to focus on improving user experience, which is why we're here. We're here for the user ultimately. We do that by performing what we call our Oracle architecture or database architecture optimization. Optimization is really focusing on a database architecture and understanding our footprint in terms of technology resources, our requirements in terms of business demands, and aligning those within a cost model that is feasible and financially scalable, and in doing so ensuring that we also remain compliant in terms of license usage. We deliver our solutions on the back of blueprints which aim to lower risk or eliminate risk altogether and ensure success, and therefore eliminate the idea of often we find customers feeling they've been treated as guinea pigs or rat labs, as we say. Often when it comes to new technologies, we like to provide assured success and first-time implementation success at all times. We do that by establishing very detailed blueprints which have a tremendous amount of due diligence around hardware and software and applications. And ultimately, we provide all of this, the full spectrum of services, which ends in a customer obviously engaging us with either a partial or a full spectrum of services for database support. And specifically around the keyword there is proactive database architecture management, ensuring that environments are kept healthy and pristine and they don't degrade over time when it comes to performance. And ultimately, that's our goal, is to ensure that the highest level of uptime and performance. So why are we here today? We're here today to address what we commonly find in most architectures, which is traditional computing environments suffering from silos of hardware, storage, and software and applications. Silos means inefficiencies in terms of implementation of hardware. Silos means inefficiencies in terms of licenses that are costed and applied to specific applications or business units. And ultimately, the silos have a lot of embedded headroom or wasted computing resources that can be consolidated potentially and consolidated for the goal of greater efficiency and greater agility. Historically, this has been around for some time in terms of objective. Database consolidation is nothing new. However, the level of confidence that people have in technology to be able to support these initiatives have previously may not been there. So when you talk about traditional legacy architecture platforms, that may be subject to typical bandwidth capabilities of storage or networks, the headroom or the performance capabilities of those specific architecture options hasn't previously maybe provided us the level of confidence we need to be able to really commit to our business users that yes, this consolidation will work, and yes, we will not have issues with multi-tenant environments and so on. And ultimately, the advent of some of the new technologies we're seeing now allows us to do that and achieve that. So, in addition to consolidation, the other thing we're challenging or asking ourselves today is, why do we take on the complex task of IT infrastructure integration? That's a major challenge for us on a daily basis, getting various hand providers to work with HBA providers, working with network interface cards, with storage infrastructure, with server infrastructure. Ultimately, we don't buy our cars this way, so why do we implement technology this way? If we're buying our cars from all the various parts, who's going to provide the overall warranty? Who's going to provide the specialist skills to maintain this? Who's going to ensure that our car operates at the highest level in terms of performance? So obviously, if we're not doing this with our daily lives, then why are we doing it with the technology? And then ultimately, that's what we are here to talk about. So if we look at today's architecture and how it typically evolves, ultimately architectures typically get refreshed every 3 years. We get an incremental increase in servers being faster, CPUs being faster, maybe more memory being allocated, faster memory. Storage evolution has evolved somewhat, but maybe not in a revolutionary manner. So all of these things ultimately, lead to things like storage bandwidth increasing over time from 1 gig to 4 to 8, and that's 10 with NFS on over 10 gig. Various protocols, which is still commonly prevalent between iSCSI, fiber, and NFS. And again, our spinning drives haven't tremendously changed from our 7.5K RPM SATA drives all the way to our 15K RPM fiber or SAS drives. And you may also ask yourself, well, there is something new happening. There are new vendors in the table around the market now who are talking about, flash storage, people like Ramsan, vendors such as Violin. But ultimately, they're doing it at the hardware storage level without any real optimization when it comes to compressing data or addressing the limited storage bandwidth we have in our architecture. So yes, storage is getting optimized at the back end. What's the point of putting a faster storage platform at the back end if your bandwidth to that storage and delivering the storage is still limited, and the protocols you're working with are still limited as well. So here's a good example of a typical architecture, something recently that we assessed for a customer in Europe, where we looked at their current estate, looked at their current architecture, what they were achieving in terms of levels of availability, what they had in terms of various Oracle servers providing different CRM or an ERP, as well as warehouse capabilities in terms of reporting capabilities, and ultimately documenting the environment in detail for the customer. What it really led to us being able to do was to help the customer understand that they were running an architecture with these particular KPIs in terms of how many processes they were running, what their KPIs were around performance, backup times, operational reporting, and so on, but ultimately what their physical footprint was with the architecture. So in looking at that, as we do being objective architects, we provide the customer with an option around what they could do with their current architecture and optimizing it. And in doing so, some level of consolidation was achieved here in implementing rack to provide high availability, but also to implement the consolidation on rack clusters using their current hardware stack in terms of their existing storage infrastructure as well as their existing servers. And in doing so, we certainly did save them some money when it comes to license footprint, going down from 54 processors of Oracle down to 36 licensable processors. But ultimately, the KPIs around performance stay the same. The amount of response time on our transactions, our batch processes, data loads, nothing changed dramatically there. So that's still a concern. And of course, our physical storage usage in our data center space pretty much stayed uniform as well. So yes, it was a good first step, but ultimately what we need here is not what we typically get, which is our IT, our business users and our management asking IT, I just spent a few $1 million here. Yes, we've got a nicer new architecture, but what have we achieved? I'm not seeing any business capabilities. I'm not seeing any dramatic increase in performance. We've saved some money, but I want to see a lot more for what I'm investing in IT. And again, we haven't addressed our complexity, the multiple vendors that we have to support, and I continue to be challenged with complex IT upgrades, which involve high levels of outages and downtime. So what do we need today? We really need a revolution, something very significant in terms of a change in the way we do things. We need a quantum leap in our business capabilities. We need a quantum leap in our user experience. Our operational efficiency has to be changed dramatically in terms of what we typically are challenged with in terms of size of backup files, the amount of bandwidth we occupy in terms of DR application strategies. Really need something that's going to free up from our common challenges that we often have to go back to management saying, sorry, it can't be done. This is all we can do with the current toolkit. We have to really change the way we see things and ultimately really reach for some very, very significant objectives in reducing our data volumes by at least 10x, increasing our performance by 15x, and ultimately dealing with a lot more of a granular and manageable architecture which provides greater agility and removes the common IT barriers. So in doing so, Oracle has done something very, very smart, we believe, in acquiring Sun. In their acquisition of Sun, what they were able to do is to take complete ownership of the entire hardware and software stack, puts them in a unique position, and some might say unfair position, but a very unique position where they can optimize hardware and software and deliver appliances to deliver a pre-engineered solution which removes risk, allows faster deployment and faster time to market, lower overall total cost of ownership, and greater performance. And ultimately, the message is running Oracle on Oracle will be a faster, simpler experience for everybody concerned. So Exadata is ultimately the high end in terms of the flagship product when it comes to database infrastructure optimization and a appliance-based architecture. Again, providing an increase in quality of service through performance and availability, increasing agility by consolidating a lot more environments into a single cluster, and reducing IT costs through significant capital expenditure and lower operational expenditure as well. Ultimately, reducing complexity because we're not spending all our time pre-integrating these technologies. So how does this all work? Well, I'd like to introduce you to Simon Rice, one of my lead architects, who will now talk through the technology behind Exadata, what makes it different, and I will loop back towards the end.
Thanks, Edward. So I think one thing we need to be careful of is not drilling down too much into the technical details on this thing. I think from a business point of view, we don't care whether it's a Westmere processor or a Sandy Bridge processor. What we care about is the business capabilities that this server enables for us and the return on investment that it can give us. However, I think what we'll do now is take a look under the hood and actually see what's in Exadata that makes this version particularly scream. So this slide just gives a high level, really around the secret sauce of Exadata, which is a combination of extreme compression of data and a 10 times compression ratio is pretty conservative there. Smart storage that can reduce your read footprint by at least 10 times as well. Accelerated delivery of that data from the storage system through to the database servers of at least 40 times over a traditional network, and a smart cache which can hold an enormous amount of data in memory. So the combination of those four factors is really what gives Exadata its blinding speed. So we're going to drill down into each one of these and just take a quick look now at how these work. So this slide really demonstrates how a traditional SAN works. Your database says, I want some data from the sales table. The SAN will at the very least return the blocks that contain that sales table's data. But those blocks won't just return the rows that the user is querying. They will return, obviously, all rows within that block because the SAN has no idea what data is in the block. Exadata, and I think we know this traditionally, this has been a feature of Exadata for some time, is more of a row server. The storage is actually aware of what rows reside within each block, and the SAN can be intelligent in what data it returns. And this significantly offloads the querying capabilities to the storage servers away from the database servers, and means that far less data is actually returned. Moving on, and similarly really on the storage side, traditionally we've seen fiber channels and other storage channel networks become a bottleneck, regardless of the throughput really. What Exadata does, and again this has been in the X2 at least, is introduce InfiniBand between the database servers and the storage cells. So not only are you reading less data from the storage cells and returning that to the database servers, but it's being returned at a much, much more rapid rate. Moving on to the actual spinning disks themselves, I mean, we know within disks, sure they're getting faster, but we're still looking at around 200 IOPS per drive at a maximum rate, and that's if you do clever things with inner and outer striping. So you have all these factors. You have your rotational delay, your seek time, your controller bottlenecks on a traditional drive. What Exadata does is it's kind of clever and extends across some of Oracle's other engineered systems. It introduces enough flash memory to effectively run all of your data operations from memory rather than disk. So even within the smallest Exadata unit, which we'll look at shortly, we have 2.4 terabytes of flash cards enabled for cache to the Exadata. So we see certainly sub-millisecond reads, and our tests really do return in nanoseconds for these reads. Oracle will automatically manage this. But bearing in mind the compression of that data, if you have 10 times compression, even on a 2.4 terabyte flash cache, you can fit at least 20 terabytes of data in there. So effectively, the outcome of that is that you don't read from spinning disk, you read from flash cache in sub-milliseconds. Compression again, so in traditional databases there is no compression. Even with advanced compression, we see typically around a 2 to 3 times compression ratio. Within hybrid columnar compression, which is enabled on Exadata, we compress down at the column level. For active data, we're seeing at least a 10 times saving for active OLTP style data. For archived warehouse data, we're seeing anything up to around a 50 times compression ratio. So your compression could be absolutely huge, and as it says here, that then filters down to the flash cache and how much data you can fit in memory. So again, on the smallest Exadata available right now at the cheapest cost of entry, you can fit at least 20 terabytes of data in cache. Some other things to bear in mind. Sure, you've got your 10 times compression. We've demonstrated that within Cintra here with an Oracle Business Suite database, which we moved on to an Exadata platform and immediately received a 19 times compression ratio on that database. So it's certainly something we've seen for ourselves as well. It's extreme compression for warehouse data or OLTP data, as I mentioned. So you have your 10 times fewer reads, that's great. You also have 10 times more efficiency in memory. As I said, you don't need to read from spinning disks anymore, and your backups are that much smaller, both your online backups and your offline backups. So you have a cascading and compounded benefit from that compression. If we look here, there's a quick table just demonstrating, say, for example, a 2 terabyte database here. Uncompressed, we have about 2 terabytes of data. We have, again, 3 terabytes of ASM, 5 terabytes of FRA, and your usual requirements for a backup requirement, your DR environment, and your development and test environment, which comes to around 24 terabytes read from disk. If you enable advanced compression, that shrinks it down to about 800 gig of actual data, a 9 terabyte total footprint across your estate, which is read from disk and memory. Whereas if you had HCC, the very worst you'd be looking at is around 160 gig of data. And in total, across your entire database estate, you're looking at less than 2 terabytes of storage, which for your data itself would be read exclusively from FlashCache. So you're looking around at a tenth of your storage requirements and blinding performance for the data that's stored there. So why is Exadata X3 different? I mean, we've already mentioned that there's a larger cache, but if we look at the evolution of Exadata, we go from what was effectively a warehouse server and certainly had more benefits for warehouses than it did for OLTP. It was expanded to provide more benefits for OLTP in 2009. The X2 servers were scaled up with better hardware, but the X3 really changes the game with the massive amount of flash included. And that's why Oracle call it the in-memory database machine. So yeah, I mean, some figures on this, and particularly this point at the bottom, the amount of I/O that these flashcards can handle is absolutely shocking. I mean, you're saying here, it's a game changer. It's 1,800,000 IOPS from SQL itself. and proven against actual SQL. So as it says at the bottom here, a single quarter rack of X3 can handle more I/O than 3 full rack X2 servers, and you know, X2 was no small box. So if we look at the other game changer, which is the lowest cost of entry into Exadata ever, the Exadata 8th of a rack, which has just been released. If we look at the tech specs on here, again, you know, I don't think we should get hung up on this, but it does have the latest processors. It has 8-core CPUs. It has 128 gig of RAM per server. It has, as you would expect, 10 gig connectivity to the rest of the data center. As I mentioned, a really key feature is the 2.4 terabytes of high-speed flash within the storage cells. And the storage cells come, as Exadata always has, with the option of high-capacity drives or high-performance drives, where you trade off usable storage versus speed of storage. However, as you're typically going to be reading and writing data from flash rather than disk, in our opinion, the high-performance disks are probably not the way to go. That high capacity would be sufficient in most environments. The last point on here is that another key feature of the 8th of a rack Exadata is it's software upgradable to a quarter rack. So in actual effect, the hardware you're buying is a quarter rack server, and half of the cores, half of the disk drives are disabled out of the gate, and you can enable those with a simple software script. So I'm going to hand back to Abdul now to talk about how we would expect this technology to impact your actual business.
Thanks, Simon. Good job. So really, I think ultimately, you know, the key message here is, yes, the technology is cool. Yes, it's blindingly fast, but what does it mean to our business? This is what it means to our business. Ultimately, game-changing metrics in terms of KPIs for the business. Batch processes coming down from 5 hours to half an hour. You know, reporting end of day or intraday reporting coming down to minutes from hours. Analytics similarly coming down. But ultimately, of course, our user experience dramatically increased from, you know, a few seconds down to milliseconds. Really turns the performance profile, you know, into a different realm in terms of evolution. Worth mentioning as well, I think the other key factor in terms of the Exadata X3, what makes it uniquely different in terms of now viable and very valuable to the OLTP world as well, it's its ability to commit writes to the cache, FlashCache in memory. So ultimately, our reads and writes are served from cache. Historically, if you can imagine, when we talk about cache-less SANs, they're typically just front-ending the cache for reads. All writes are going through the cache in a write-through mode to the spinning spindles, which is why we worry so much about how many spindles, how many IOPS the SAN can provide. Ultimately, the high-capacity configuration in the Exadata makes a lot of sense because we are not hitting physical spindles. We're hitting all our reads and writes to cache, which is a key point. So going back to our company that we evaluated earlier, let's look at now what the new architecture looks like in an Exadata footprint. It's ultimately now a lot more condensed, a lot more consolidated with a tremendous amount of increase in capability around performance. But we've also reduced our core count because now we have smart technology at a storage level. It's not sending so much data. When it is sending so much data to the compute nodes or the data servers, it's doing it in a more efficient manner over InfiniBand and bringing down our performance KPIs quite significantly, as well as our Oracle database footprint in terms of our core count gone down very significantly as well. Our storage size has been decreased tremendously, and ultimately the amount of data we're backing up, how long it's taking us to back up, and when we're sending it to remote locations has benefited tremendously as well. So one thing we haven't talked a lot about is the word cloud. Now, ultimately, we didn't want this to be a cloud discussion, but that's essentially what we're talking about here is leading businesses and our customers towards the strategy of a private cloud. Private cloud is an on-premise consolidated architecture, not to be confused with a public cloud, such as Amazon and Oracle's on cloud now. But really, private cloud is the ability for IT to confidently go to the business units and say, we have a shared infrastructure on which you can deploy your business applications, and here are the cost elements and the breakdowns of the compute and the I/O that you're using, and therefore have an internal chargeback policy and accounting as a result of that. But these are the real business drivers. Having the ability to confidently build an architecture like this, to do it quickly, to reduce the costs, and to increase the quality of service to our businesses, to our customers. So Cintra ourselves, we believe in this technology. We're not just, we're certainly practicing what we preach, And just recently, we have ourselves invested in our own Exadata. We are in the process of building a global Exa Revolution Center, as we call it. And that Revolution Center will include the Oracle Exadata X3 platform, the Oracle Database Appliance, and also the Oracle ZFS Storage Appliance. All of these are compelling products which all deliver the same message around simplicity, rapid deployment, lower cost, and greater performance. A tremendous capability that we're looking forward to demoing and provide as a test platform to our customers very shortly, and we look forward to that. So just finishing up very quickly, all of this is ultimately, Cintra is here to provide services and guidance to our customers in terms of taking on these architectures. In doing so, here's a full spectrum of services we provide around early stage assessments, to road mapping, to detailed design and blueprinting, to the actual configuration, implementation, deployment, support, migrations, upgrade, whatever you can think of around getting from a particular version of Oracle to a legacy platform to Exadata. We've got it covered here, including the ongoing proactive 24/7 support delivered from our UK and US operations. So ultimately, Cintra is here to be a little different from a typical vendor. We're providing an extremely high level of expertise when it comes to Oracle infrastructure. We're providing an objective advice. We'll tell you what's good and bad about any technology. We'll ultimately deliver that in a blueprinted mode to lower the risk and ensure success at all times, and provide you with a full spectrum of services. And ultimately, the key word here is ownership by vendors such as Cintra is key for our customers to have the confidence in us to deliver these technologies and to ultimately gain our customers' trust. So what's next? Where do we go from here? And just to wrap up, really, Cintra is here to provide you, the customer, and the organization looking to assess the current architecture, where you have opportunities for immediate optimization within the current tech stack, but also setting out a roadmap for a strategy towards a consolidation platform, whether it's Exadata, whether it's the Oracle Database Appliance, whatever makes sense for your business in terms of performance requirements, cost and financial constraints. All of these things will be considered ultimately to provide you with a very detailed roadmap towards where you should be headed in evolving your database infrastructure. And ultimately for a long-term relationship with Cintra as a partner for expert Oracle guidance. So here we can just quickly wrap up on some key contacts for today. Simon and I will be available on our emails as well as located here in New York. And of course our sales team is always available. And if you already have an established Cintra account manager, then certainly follow up with them as well. So thank you very much today. Thanks for your time, and we'll be continuing to provide these short webinars in terms of various topics, and look at on our website for more interesting topics. Thank you.